We are about to start. Aspetto per qualcun altro. Ma manca metà della gente. Okay. Okay, good afternoon, everyone, and welcome to this third session of the Digital Building Permit Conference. I'm Silvia Mastrolembo Ventura from the University of Brescia, which is in the north of Italy, and I'm going to chair this session about organizational systems. So we are going to discuss challenges, barriers maybe of organizations, in particular public authorities, in digitalizing their processes, with a focus, of course, on building permit. Today, you will see a very interesting presentation from a huge panel of interesting speakers, and I think some keywords will emerge, starting from digitalization, of course, but also sustainability, education, and it's time to start. So the first presentation will be given by our keynote speaker. The keynote speaker is online, so okay. Hello. The keynote speaker is Hannele Kerosuo, who is a senior researcher at the University of Helsinki, and she will discuss the building permit process, but from a social science perspective. So, Hannele, you can start when you want. You have around 20 minutes. Thank you.
Okay. Hello, everyone. Good afternoon. I hope you can hear me well. And I hope you had a good lunch so that you have energy for this session. So I'm Hannele Kerosuo from the University of Helsinki, where I have been a long-term member of Cradle Research Group, which is a group in the Center of Research on Activity Development and Learning, led by Professor Yrjö Engeström. And I'm also a visiting researcher at the Tampere University in the Faculty of Education and Culture, and a research group there. So I'm going to talk about building the permit process from social science perspective on the basis of my experiences of studying implementation, building information modeling in building industry. And as you know, a social science perspective is an approach of many theories and methods. And my approach is based on social practice theories and on its one representative, which I know quite well, which is cultural historical activity theory. Sorry, I have to use notes in order to keep the time. So, okay, I have to remember change the slide. I wonder how it goes. We didn't test this. So it doesn't work on my computer. I'm sorry, I don't know what to do. Do I have to do it? Do I have to do it somewhere else?
Hannele, maybe you have you tested with just clicking the mouse or the keyboard?
I use only keyboard. I don't use mouse. So should I be using it on this very small screen of Teams somehow?
Would you like us to share the slides instead of you?
Yes, you can do that, because it doesn't just work on this screen at the moment. So I'm doing the second slide at the moment, or I want to do the second slide.
Yes, because we are still seeing the first one.
Oh yeah, it just doesn't work, and I don't know why.
Look, you just need to click on the right arrow over there in the...
Shall I stop sharing now myself?
No. You can see an arrow on the bottom of your screen. Now we are with
Hannele, can you please share again? Hannele? Hannele?
Yeah.
This is Judith. Hi. Can you share again, please, your slides?
Okay. Let me see how I can do that. I have to. Oh, this is really a problem.
As we did before, Hannele, just to share.
Yes, but because I have closed the. Okay, and so there. No. Now I have stopped sharing.
No. Now we can see your slides.
So now we are sharing your slides, and you have to tell us when we have to switch, okay?
Okay, you can switch to the second slide.
Thank you.
Thank you, Hannele.
Can you see it entirely, because I can see only half of it?
Yeah, we can see it entirely. We can see it. Yeah.
That's okay to me, because I have a copy of my slides.
Okay, great. Thank you, Hannele.
Sorry about this, but there are always problems.
Don't worry at all.
Yeah. Okay, so what is cultural historical activity theory? Many of you maybe know it quite well already. I know some of you know it. So it is a general approach for studying human activity carried out by human actions in their relations to socio-cultural environment. And it originates from early cultural psychology by Vygotsky and Leontiev, and was created about 100 years ago. But luckily, it was introduced to a wider audience in the West by Michael Cole from University of California, San Diego, and Yrjö Engström from University of Helsinki. And during the years, it has developed a far-reaching practice approach into third-generation theories and into the emergence of the fourth-generation theories that we are working on at the moment. So what does chat offer? It offers possibilities to understand the role of objects in human activity and sensitizes us to the conflicting dialectic and developmental nature of practice that many of other approaches are lacking, says Davide Nicolini, who is very well-known practice theorist and a very good colleague also. So the next slide, please. So my purpose is to introduce the basic theoretical concepts and tools of that. Oh, sorry, I hear my own voice. It's terrible. With examples from studies conducted in Finnish BIM projects. And these concepts are object-oriented activity system, contradiction as a driver of change, expansive learning and learning actions in development as solution, as enabling solutions of contradictions. And the next slide. So here you can see a person working on a physical object with a computer application tool. But there are more we can also see. There are other factors involved in this activity or action, actually mediated action. computer-mediated action on an object. The subject is certainly a member of some community or other related to some other subjects. The community has also agreed on some division of responsibilities between them, as well as some rules. On the following slide, I will present the famous general model of human activity created by Professor Engeström. This is a very well-known model and used a lot in various places. And as you can see, object-oriented activity system is constituted of subject, object, outcome, instruments, rules, community, and division of labor. And the subject may be an individual human being or a group. And then what we need to know about the object of activity is that it is more than the material or physical object. It also involves the purposeful target and motivation of the activity. It is something given by our context, and it's something we are anticipating. And what is important to know about activity systems is that it is constituted of relations. They are not categories as quite sometimes are understood, but they are relations interacting with each other within its socio-cultural environment that is constantly challenging these elements of activity. So activity systems are connected to other activity systems in real activities and practices. So there are two examples of connections between design and construction. Above, they are sharing part of an object, and below design activity, the object of design activity are these the creation of digital objects such as models that are used as tools by construction activity. And next I will present an example in the next slide about a future prison as an object of activity in a multi-party workshop, in which 4 groups of participants were giving feedback about the object of design to the property owner of the building and to the design group. And in the next slide, you can see some examples of the models that the designers, architect designers, did using by BIM. And what was surprising in this case was that the representatives of the prison service provider, national one, were not totally satisfied with any of the models, although they were carefully designed. But this service provider presented their own model that they had created and called an X chromosome. And then you can, if you put on the next slide, I can tell you about the reactions this X model created within these groups. So there was a lively discussion and different perspectives were raised and confronted. For instance, economists from the property owner, national property owner of these kind of buildings, said he was for instance, agreeing with the new ideology of the prison activity that was embedded in this model and idea that the service organization was presented. You know that in the studies of space, Lefebvre, who is very famous, he is saying that ideologies are embedded in built environment, and there is some kind of battle going on when there are some changes emerging. So I could see that there were some ideologies of how to conduct prison activity in this case going on. So the economist was saying, I was thinking how to rebuild without the risk of bringing about the old culture. But the employee of the prison was just wanted to preserve the culture. And he said that it is central to them to remodel the activity, but this model, this X chromosome, shows one's bottom to us. It's a saying. And then the concept developer from the service provider organization was, of course, for renewing the activity. And they had been discussing that there was no way that an authoritarian center of power would remain in prison, in the prison context. Well, in spite of these disagreements manifested as a contradiction between old and new ideas of the future prison building to the ideology of prison activity, the project continued with the creation of new models that were agreed with different groups, and the prison was built with every participant's satisfaction. However, we were not able to hear the view of the prisoners about the new buildings. So this study is not perfect in that sense. Okay, then I could say a few words about the contradictions on the next slide. So contradictions are historically accumulated structural tensions between opposing forces of an activity and between activity systems. In organizations, contradictions can be manifested in many forms, such as errors, disturbances, disconnections, and gaps, etc., that I have been studying, and also as dilemmas, conflicts, critical conflicts, and double binds in discussions. There are many examples in the literature about analyzing contradictions, and there are some few examples in building production industry, like for instance Petr Gade has studied dilemmas as manifestations of contradictions in collaborative building design setting. Peter is presenting today, I think. Then Fredrik van Amstel, an architect, has examined contradictions as design constraints. And also Sahedi and her colleagues, I think she was also an architect, studies contradictions as drivers of collaborative design. So there are much literature about this. And I have few examples. I can see that I'm running out of time. So there was a school project where they were implementing BIM. And I think we have to go to the next slide so I can tell the example perfectly. So the contradictions emerged in this process between interfaces of participants, and they emerged in the interface between design disciplines, so that when they were running BIM models, they were real design errors, but they were difficult to see there were plenty of them, and it was difficult to separate them from technical errors. And even if they used this integrated model, IFC model, and as a consequence, shared use of the integrated model, they needed to create a special meeting and a series of them that lasted quite a long time, and also made the process slower, with some consequences to the building processes, so that in the interface between design and construction there were disruptions, because designs were handed over late to the construction sites. And then if we think about the interface between design, construction and operation management of the buildings, there were disconnections between digital tools, and actually they didn't have effective tools in the operation, effective BIM tools in the operation of buildings. And the interface between design, construction, operation and the client and end user was totally lacking. BIM was disconnected from the uses of them, and they used old methods of giving feedback about the designs and plans. But then there was some expansion, because one architect, besides only showing visualizations of BIM models, also presented a model so that the users and client could comment the model throughout it, like inside the model. Okay, and how much do I have time, because we started a bit late?
Hannele, actually, the time, I think you have 1 minute to go to the conclusion.
Okay, so in my presentation, I have to skip expansive learning and learning actions as solutions to solving contradictions. But you can find literature about that quite a lot. And there are lots of famous methods, such as change laboratory, that are used in interventions in practice. And then the final slide. So in what way can chat enrich digital building permitting? My thoughts are so that they can enable researchers and practitioners to develop complex and evolving professional inter-organizational practices and processes. An activity system could also be used to clarify a systemic whole of an activity and its relations in concrete situations and concrete practices. An object of activity is important because it can be used to illustrate the purposes and targets of an activity and its development in inter-organizational practices, because different participants don't usually agree on, they don't have the same perspective, so it would be important to discuss them. And the analysis and reflection of contradiction is important too, because it makes possible to specify a direction of learning and development in organizations. So this is finally the end, and sorry, I missed one part, but I hope you could find it.
Thank you, Hannele, for your presentation. There is maybe the time for a question, if you have. No question for Hannele. I think that your presentation was quite useful also to start thinking about how the people are play a key role also in the digital transformation, and can be an important aspect to be considered for the development of digital transition. So thank you very much, Hannele, for your keynote speech, and I hope to meet you in person very soon.
Okay. Thank you.
Now I would invite Professor Wildenauer to join us. And we are going to talk about how organizations should think differently about building design. And he will propose, I suppose, an integration between the building as a service model and the topic of digital building permit. I will use the science now.
Thank you very much. It's me again. I'm sorry. Hopefully I can wake you up after the lunch. I mean, and the alcohol. My topic is the adaptability of digital permits for building as a service asset, and I'm quite happy to present it today here in Barcelona. So, well, I think you know me. The picture is 1 year old. I still look the same after working 1 year at the university. So I'm professor for digital construction, but that's enough about me. It's about the topic. So the thing is, we have to talk about sustainable development, especially in our construction industry. And just to give you a clue, for example, in Switzerland, most buildings are planned and constructed for 100 years, but they are demolished after 30 years. So that's not sustainable at all. So I think that's the reason why we means Professor Underwood from the University of Salford, Manchester, and I started to think a bit differently how to think about a construction project. So, and I think in the discussions we had, I had so far, everybody was thinking that BIM is not the solution, but more and more the problem to all our stuff. So, I don't hear any complaints, so okay. Just to give you a clue, we are building the campus in Biel, Bienne. It's a bilingual town in Switzerland. We try to combine French and German. So, this is how it looks now. This is how it should look, maybe in 2027, and that's the building model to it. And to give you a clue, that's the largest, I just wanted to say BIM model, but it's the largest project for digital construction in Switzerland, meaning around 500 million francs. And just to give you a clue, that's 30 times the St. Gotthard tunnel, just to give you a clue, or 2 bank bailouts in Switzerland. So typical bank bailouts. So in 3 years it should be built, and the question was, we have maximum capacity while the term or the semester is going on, but what happens in between? I think you can see the bushes going through the floors at every university in the lecture-free time. So that was the main research question. What happens in the lecture-free time? What do we do with the rooms? What do we do with all the theaters, etc., etc.? What do we do? And yeah, that's exactly the point, how to maximize the use of this building while maintaining flexibility and modularity. So that was one of the main questions, and that led to some interesting questions, because the building permit is just for one purpose, education, and not for renting it out to the public or to renting out as a startup space or whatever. So it's just for educational purposes, the permit. What happens if somebody hurts itself in a startup space, which is in the university? So interesting questions. So the fundamentals, I'm just clicking it through. I'm not sure about the time, but you give me the time. So left. Oh, okay. Okay, good. Got a heart attack, okay. So the basic functions of a building, I think everybody knows that it's structure, system, services, management, and the interrelationship. Then that's a definition of Adrian, a colleague which I really appreciate. She did a great job in this fundamental definitions of building. And the next thing is that we have to think about the demand of a building, or the demand of the spaces in the building. So we have to think about the OPEX and not about the CAPEX. OPEX is the operational expenditure and CAPEX the capital expenditure, because it reaches out by dozens of times the OPEX, the CAPEX. So we think in this research that the focus should move, or shall move, from services in a building to view the building as a service dominant, logic-based asset. I'm sure, yeah, it's a difficult topic to talk about services in the construction industry, but still we have to be more service oriented. We should be, at least. So the interesting thing about building as a service is that users become recipients of services of the building, because the building is equipped with sensors, beacons, whatever, and the building can offer additional services, and not only of the services in the building. So I will come back to that later, because the challenges with traditional building permits, I think we've all heard of that, and especially in Biel, in the campus Biel, the topic is that we have to change to more dynamic data. We have to know exactly how much energy we spend, or how much energy we produce, because it's solar, etc. And so we have to think about real sustainability, as I call it. And we have various limitations by the traditional building permits, as I just mentioned. A building permit is more or less like focusing on one specific point. And even in Switzerland, we have to talk about resource efficiency. We can't build for 30 years this campus. It would be an absolute waste of taxpayers' money. And we need to think about the building to become extremely flexible and adaptable. And the campus we are now in, I can tell you, it's only 25 years old. Because it's 25 years old, but it's not working anymore for modern teaching purposes. So modern, I don't mean whiteboards, etc., but it's just not flexible enough to separate rooms, etc. And the last point, as I already mentioned. So what Jason and I did was talking about the current status or current approaches. We're talking a lot about BIM, and I think Cyber was the company you said, or something about beyond BIM. Where is he? Country? It's about BIM, the digital twin, and we're talking about these abbreviations, but nobody knows what it is. At least in my opinion. If you talk about BIM, I think let's say we have 150 people here, we will have 160 different definitions of that. Exactly with the same with the digital twin, cyber physical systems, and the data fusioning, as we called it, to get all the data necessary for the building. So what we need is more like this approach. We need to combine everything. So, and it will get more clear when I show the next slide. And you see a lot of, as a service, and don't have a pointer, so I have to use my finger. We need data collection, and this can be done by infrastructure as a service. And this leads to a data fusion, as we call it, which can be performed by a platform as a service to enable users to make qualified decisions. Sounds easy. It's not. that's what we came up afterwards. No worries, I won't guide you through, so it's too much to talk about. But I just want to draw your attention to this little yellow thingy here. That's the human in the loop. That's the most important part. The human must be always informed about the possible decision he can make. So unfortunately, it's only a little thingy on the right-hand side. Right-hand side. So I come to an end because otherwise I get kicked today. So the mutual benefits between the digital permits. So we have to be more agile. And I know when I talk about digital permits, agile is not the word you connect with the digital permit or the building permit. So we need to automate processes, but I think I was impressed by Nick's presentation in the morning and by all others. But we have to focus on the service the building could fulfill over its lifespan, to think buildings in a new way, and not only to think, well, it's an educational building, which educational services can the building offer? So, and there are a lot of interfaces which we are trying to research, and I have 25 years to my retirement, and I think I will have a lot of, well, 30 or whatever, so we will have a lot of research work for that. Just to sum up, if we think about the Sustainable Development Goals, which we should all aim for, we need to rethink buildings in a new way. And we need to address these highly flexible and multimodal and multifunctional buildings. They are not covered by digital building permits so far. And the other point is how to respond to traditional permits. If we want to change, like in the campus, we wanted to offer these new services. Just not possible. The building authority said, nice try, you can do, but we cannot prove it. So, chicken egg topic. So, and we will use this campus to implement small, tiny approaches of this large map you saw on the screen, just to see if it's working and how we can implement it later on. And for that, I think I'm almost on time. Almost. Okay. Thank you very much.
Thank you. Thank you very much. So we continue to talk about people also in this presentation, and also we introduced the keyword of sustainability that is very connected to the digitalization of the built environment. There is any question? Yes.
Don't you dare. Oh, it's Nick. Oh. You had an excellent presentation, Nick.
And yours was almost as good.
Can't hear you.
Would you like to run the regulations backwards so that they told you what activities you may carry out in the building, instead of what we do now, which is you choose an activity and then you tell if it's legal or not?
Yeah.
But one of the things with my logical approach is that we can run it in any direction and say, if it's built like this, then you can have public assembly, or you can have private gatherings,
Exactly,
or you can
yeah.
have
Yeah.
things. So
Yeah.
that's very possible.
Yeah. Oh, it was not even a question. Oh, excellent. Thank you.
Did you want to?
Yeah, of course.
Yeah.
We need to. We talk later.
Okay.
There's another question from Bentley.
Where
have-
are you?
Sorry.
Yeah.
It's not for sale yet.
No. So what will be the challenge? I mean, I understand we have a use and then you get a permit and then you get to use it that way. But after a while, I think things change. We cannot look into the future. And what is the problem with asking for a new use, right? And a permit for a new use? That has been done with buildings in New York nowadays. They reconstruct the whole interior and then rebuild it, right?
Just right in Switzerland.
Okay. So basically what you're saying is you have to tear building down and build again? Is what you're saying, that the setting in
That's
Switzerland?
most of the time the current approach in Switzerland.
Okay. Okay. That's the answer.
Mostly. It depends on the canton, of course. No canton discussion now, please. But yeah, it really depends on the use of the building. For example, our university campus where we are now will be reused for nurse school, but it's still used for education. So the thing is the same, but we couldn't change to a hotel, for example. Not that easily. Depending how lucky you are with the building authority.
Okay, thank you very much. And we remain in Switzerland with the next presentation.
Okay.
Yes, that will be given by Matias Penrroz from the Bern University of Applied Science, and they will discuss the role of university education in supporting the change towards digital and sustainable processes.
Thank you. Hi everyone, my name is Matias Penrroz. I'm from Chile. Funny to be here speaking English and working in Switzerland. So following the line of thoughts from Adrian, my presentation is starting with why. So we saw this morning the golden cycle, briefly there. So shaping the future generation of planners by empowerment of necessary competences at universities to enable digital construction. Quite a long title, but I will explain it in the next minutes. That's Adrian. So shortly about myself, I'm a scientific collaborator at the Bern University of Applied Sciences. I have a degree in architecture from Chile. I went to a really artistic school. Before coming to Switzerland, I worked 5 years as an independent, having a construction and architecture company. So I work in the industry. I know a bit where the pains are. And I came to Switzerland for the Master in Wood Technology. So it's a combination of civil engineering for timber engineers. The reason I'm telling this is because I've been trying to work in the past 10 or 15 years to understand the languages of both architects and engineers, how to make collaboration a bit better. I know it's not easy. We both speak different languages, but I think we can combine a bit of those. Context, the 17 Sustainable Development Goals to reach the international treaties and enable a real change, of course. Why I'm saying this, because if we see them isolated as isolated goals, it's not going to work. So the role of universities to enable this change, to teach new skills and competences, is to empower students and the new generations to understand them as a system. These goals can be, of course, structured in different categories, different layers. We all know that. But we cannot lose or not see the big picture, how they are organized, and how can we solve these interdependent challenges. So they are all connected. That's what I try to tell our students, the new generation, to think in a more holistic way, to think about them into their connected, independent of their background. So we have engineers, architects, timber constructors, we have carpenters also in our programs in Biel. And how do we integrate this into teaching? That's a big question we have having so far. It's because we heard a lot of the industry today. We know that there are many problems in the tools, softwares, of course. I'm happy that we spoke about processes as well. It's not always the tools. The tools are not going to solve the problems in the future. We need to create and to empower the new generations to think that this is a system and to integrate this into teaching. For that, we like to also combine this with the Inner Development Goals 2020 for this foundation. This being said, we can see them as 5 main categories. There are many skills that we need to taught to our students. So the being, the relationship to self, thinking, cognitive skills, relating, caring for others and the world, collaborating, social skills. That's a big problem, or big challenge nowadays, I would say. Acting, enabling change. Many students saying, okay, once I'm out, how I'm going to change things? How can we change the way of thinking? Can we do it actually in big organizations? Can we do it in municipalities? We have been classic answers from municipality. We have been doing this so far, like 40 years. Why should I change this? Companies as well, policymakers. And for this, now, like more or less the detail of the background, I will focus on the fourth one, collaborating, social skills, especially nowadays after Corona times. We all know that social skills in the new generation or between those years are not so easy. Everything is done in Teams, everything is done online. Why should we meet physically when we can do it online? I think that maybe the 2 to 6 years of a building permit could be reduced into 3 afternoons of meetings on site, I would say. I hope many of you think the same. So, going to the main topic, collaborating skills and the golden cycle, starting with why. Why do you do what you do? What's the purpose? How do you do what you do? And what do you do? I'm not sure if you have had the experience to send a task to a group of students and tell them you need to define a building which is hybrid structure with multiple purposes, being that educational purposes, offices, or residential. Say that to architects, to engineers in the same group, and they can not start the task. They need the protocols, they need what are the deliverables, what do I need to do, what's the format, how should I present the files, is it PDF, what? No one is asking why, actually. I've had this experience. Why should I do this? And why should we work together? That's really interesting to see that many of them start working on the 3D models immediately. They do a highly detailed model. I know that some experienced digital carpenters can automate a model with all the connections in one afternoon. Architects can't use BIM software to do walls with 5 layers. Engineers would like to have more abstract models. But everything is focusing on what to do, but no one in why. So the connection between those two is about these social skills. So they don't understand each other. What's the language of this? I think that digitalization has played a major role in this. We put ourselves in this situation nowadays. I think that the thoughts from Odilo today about the paper, it's really good. The paper is still good. So we have these 3 main aspects: beliefs, processes, and results. The beliefs are really important because with these beliefs, we can empower new generations to be solution-oriented. They can act. Thanks for the reminder. But this requires an understanding of the systems. And I'm going again back to the systems and to think about why I'm doing this and project, what are the project goals, why are these going to happen. So the processes in the middle, how do you do what you do, is also the link between those two, the why and the what. For that, we need to think about this pool planning, and the students need also to achieve this not by digitalization, but I will point this, to have these more social skills. So that being said, to achieve the collaboration for these inner development goals, they propose the following beliefs and competences. The communication skills, again, the co-creation skills, so co-create together. So to define what are we creating, how are we structuring our information. That's one of the major points. Everyone is saying, send me a BIM model. What is a BIM model? What's inside? Send me an architectural model. What's an architectural model? A structural model? What is that? So we need to have the skills to co-create together, have an inclusive mindset, intercultural competence, the trust that the work of the other colleague is I can take over of this. So many things, many times I've seen, or we have, I hope that we have all seen that you get a model, you get a 3D model, can you trust in it? Can you check it? Can you trust on the connections? Can you trust on the accuracy for the ones that doing the off-site manufacturing, for example? And this, I want to send to describe this by some examples. We have some approaches in teaching. This is the minor integral digital construction. So this replaces part of the traditional study program where we have focus on interdisciplinary work on real world problems in 3 semesters. So in this case, for example, the creation of a bus stops in the city of Biel, we engaged the municipality, the community, local companies to come up to schools and do the project with the students in the semesters. So from the idea, the client briefing through data structuring, the robotic manufacturing, those are our facilities, not the last one, but the first 3 images. Production and assembly, we're really focused as an applied science university into what's gonna be done actually. And the students get different perspectives and get used to solution and oriented acting. So by this, I would like to put the focus on the interdisciplinary, to have project-oriented thinking in cooperation with the industry. And that's really important, cooperation with industry. So industry, public and private aspects. That's what we do. In Biel, we try to be the pivot in the middle. So I think just to finish, I think that this is really important to say that the students, by doing this, have much more social skills than before. They focus on collaborating together, talking to each other, and the projects are only the intermediary aspects. They focus more on the processes, and I'm really happy that today we're focusing also in processes and not only on tools. Thank you very much.
Thank you, Matias. Any question? Maybe I have a small question. How long have you been implementing these teaching methods in your university? And if you have already seen some impact in terms of student satisfaction or also employability?
Yes, I've been in Biel since almost 6 years ago. And since I came for the master, we have been doing this in the lectures at the master and the bachelor level. And the impact is really good. It's not easy, I have to say. It's not easy to get some really deep engineers that they only want to calculate, or architects that they want to do abstract things to work together. But in the end, it has a good outcome, especially for the industry. They have people with a more open mindset, and we're getting to collaboration. I think the languages are getting closer.
Thank you very much. So I invite to the stage the third presenter, Peter Nørkjær Gade, from the University College of Northern Denmark. And in this case, we are moving to decision-making processes and their integration with the digital building permit process and technologies.
Hello. Yeah, it works. Thank you very much, Silvia. Yes, my name is Peter Nørkjær Gade, and I'm head of research and docent at the University College of Northern Denmark. I think following line of the 2 first presenters, this is of course more related to the people aspect of digital building permits. And I think related to also the last presenter's emphasis on the collaboration aspect, I will focus more on the aspect about thinking and acting today. Instead of thinking, now we have seen a lot of different technical solutions that often end out with, for example, a report. But what do we really want to obtain with these reports, for example? We want to change people's way of acting, for example, in the case of building permits. So that is what I'm going to talk about today. So from my perspective in what I've been doing some research about, and my interests is related to decision making. I've been looking at decision making as, you could say, a focus for the people who are working with this technology. Basically, is something where we have to use it to support some kind of decision making related, for example, to construction. Here, for example, building permits, as it says, it's a high critical area in the process, and as we also have discussed before, these processes is often fraught with complexities, delays, different challenges that is experienced. And also, you could say that this decision making, not only from the administrative part of it, but also for the consultants, is highly critical that we have, of course, experienced people who know when to enact the right decisions. And as an example, we can see here in the bottom, there's different elements to this, you could say, decision stressors that basically defines the quality of decisions that's made, and uncertainty, complexity, time pressures, and information overload, all elements that we experience in handling building projects in general. So basically, these things, they can cause inefficiencies. We have also sometimes, as we also explored earlier, that these processes potentially can also hamper innovation. For example, we need to do something more sustainable. Sometimes even building permits or technological solutions to building permits can hamper creativity and innovation. I think there's several examples of this. So we need to be aware of this and think it as a supporting system for people to make better decisions. One of the approaches I have done is looking into, you could say, cognitive psychology. So within that domain, we have something called naturalistic decision making, which is a field where this concept called recognition prime decision model is a part of that. So basically what it is, it's about, when we make decisions, in many cases we make decisions in environment that is complex, uncertain. We don't know all the information that we were supposed to, but we need to make a decision, and we need to make a decision now. And I think construction industry, for many of you guys that have been out there, that is most likely the main way of doing decisions, and these things happen by experienced people. This model can help, frame a way to structure information, for example, where we get from these different systems, as we have seen in a specific, well-tested model within other domains. So it tries to use knowledge and intuition to identify viable solutions. It also can promote, the right results that we want to get out of it, and it relies on this recognition of patterns and cues from experience. And I think also related to what we've seen earlier, often I think in education we have this idea that, for example, people who are experienced in the construction industry, they know these things by intuition, but it's something that is often difficult to translate into an learning environment, for example, and also even mixing with the right technology. Yes, so this model was created, in general this model is created by a guy called Gary Klein. I don't know if you know him. He has done some work together with a much more famous researcher called Kahneman, who pioneered this System 1, System 2 way of thinking. So basically he laid out this model that have been, when looking at firemen, how the good firemen, how they acted in a very pressured situation, and from that he made this model about how people, the basic structure of it, and also you could say the building blocks on how to structure information to make even better experts at what we are doing. So it gives a comprehensive framework for understanding how decisions are made, for example, in the building space, in these naturalistic settings. It emphasizes integrating three elements, especially in the simplified model here. The perception of the situation, you need the right information, you need to size up the situation pretty quickly in order to make the right decision. We need to have some knowledge about the situation, and we need to have knowledge about, the potential right actions that we can make from it. And of course, we need these technical systems to support this way of thinking. And here again, we have to remember that these things are said, again, it has been said many times that, the human still plays a central role in using these technology. Basically, we make information to people to make better actions, basically. So human expertise is key, and we need to recognize patterns in these data that, for example, we serve in looking at, for example, Solibri. You have this nice report, sometimes of many, many thousand pages in projects, basically. But how does that support better decision making, for example? So I think in general, in a lot of software development and system development testing, we need to emphasize this interface on, how does it really inform better decision making, and how can we continue to improve this? Yeah. So my you could say intuition is that, and what we have been testing right now is that we are trying to use this model related to elements from related to permit authorities to make faster and more informed decisions. And we use this general model to emphasize this in a technological setting. Just to say from some other areas, it has been very well tested in sports, for example, where it has been proven to make people act better in high stress environments. But also, of course, in regards of military. The military have been used these models to make people working in high stress situation make better decisions. There's been examples about, for example, people at checkpoints, in some cases starting to shoot innocent people, and implementing a pretty simple model like this has reduced, for example, friendly fire situation and all that. Of course, this is some extreme examples, but also the building site can sometimes be a war zone, some would argue. And also regarding to the sustainability aspect, we are currently implementing it in a project together with 2 other university colleges in Denmark, where we use some different technological systems, and we force the systems to lay out information in a manner that makes people, enable people to act better with this technology, basically following this path. So making sure that the people can size up the situation fast. We lay out potentially the right cues related, for example, to this is specifically about circular resources in buildings. For example, if you have a renovation project, you need to size up the situation regarding, okay, what materials do we have, and what can we do about it in the best way forward. The concrete result from that is coming this autumn, but we don't have it now. Moreover, we are trying to integrate it with, we are trying to develop our own large language model, where we use some of the information. There's a lot of information related to circularity, but the problem is often that, finding what is right and what is wrong in that jungle can be a mess. So we try to simplify it and lay it out so we help people act better in the building situation. Yes. So, in generally, to my surprise, this is a very under-researched field, especially related to digital construction. There's almost no research regarding naturalistic decision-making and BIM. So again, I changed actually the title for the slide today about a call to enhance some of these aspects, basically. Because the call I would like to make is that I would like to help and also to gather some more data from different projects about the potential of improving people's decision using a model like this. So of course, please come to me if you have some interesting projects we could make some interesting results with using a model like this. Yes. And potentially we hope that it can offer a promising path to revolutionize maybe even building permit processing and make it more efficient and adaptable. Yes. Questions?
Thank you very much. Peter, any question? Yes.
Thank you very much for your presentation. I found this very, very interesting, and I wanted to know if you knew what would actually be required in your experience in order to be able to apply this model of decision making. I mean, does the public authority need to be at a certain level in order to make this sort of decision? Do they have to implement certain system already? Do they have to have the information already digitalized? Because it would be interesting to see if it can actually be applied in, let's say, less digitalized
Yeah.
schemes. Thank you.
Thank you for the question. I think it's not necessarily dependent on the technological level. In general, it's a way that emphasizes in a way where complexity is abundant. It tries to advocate that sometimes we can make something simpler and more effective. And I think in a world where everything kind of getting more and more complicated for every day that goes, and people are stressed about it, and they cannot find way through all of this. Now we have new requirements in Denmark about sustainability and all these things, and practitioners have a hard time keeping up with that. So giving some well laid out paths for them to act in a better manner, so we, for example, can get more sustainable buildings, I think would be highly appreciated also by practitioners. Yeah.
Other question? No? One.
Should the behavior of the designer and the regulator be based on cues? Because that's just a recipe for Scottish dancing. The people, dance around each other looking for clues. Surely the regulations and the information is actually the fixed thing in there, and that trying to approximate it with guesses and cues. And I know regulators, the first thing they do is they look for the name of the designer, and they say, oh, we know him, he's an idiot. He always gets the fire escapes wrong, or whatever. They use heuristics to get to an answer, but it's on the basis of what the regulations say.
Yeah, I agree. There's definitely a danger in this. I think we have to acknowledge that we have pure heuristics and we have good heuristics, basically. I think especially in the early stage, we need some good heuristics to make sure that the building is on the right path. There's a concrete example in Denmark, we use the DGNB model for assessing sustainability. The thing is that designers, they don't design for DGNB. They just design as they normally do. And then at the end, they check to see, okay, do we actually comply? We hope so. But they actually don't know it before the end. So hopefully they have some kind of heuristics. It develops over time that, okay, if we typically do this, then there's a chance that we will go forth in there. So I think one does not exclude the other. I think at different stages we need different tools to this. And I think this, you could say, heuristic is already playing a part of design of buildings. But we need to acknowledge that, and we need to make sure that it's applied in a better way than it is today, at least. Yeah, I think that's the best reason for that. You are doing this. No, not happy.
Thank you, Peter. And I invite to the stage the next presenter, who is Petr Hradil from VTT Technical Research Center of Finland. And in this case, we continue to talk about the interaction between digitalization and sustainability and the integration of the life cycle assessment concept.
Yeah. Thank you very much. And one note, you have in your program written that I'm from SOVA 3D, so I'm really from the Technical Research Center of Finland. If you haven't heard about Finland, we are a small country, about 3,000 kilometers this way. We are in EU, NATO, and Eurovision, and my presentation is not too much about organizational challenges, but about automation of life cycle assessment. Well, this is about sustainability, so probably it still belongs here, but it will be a little bit different. So maybe we can agree that calculating life cycle assessment is not the easy task, and it cannot be really fully automated with current technologies. We need still some human input there, but we have excellent tools like one-click LCA or Solibri Carbon Checker or others. So we can automate a lot of things, and the main task maybe of these experts who are interacting with the models is to improve the inputs to such a level that they can have sufficient accuracy of the outputs of the predicted carbon footprint, let's say. But now we are talking about building permitting. So the question, is this correct question that we want to answer? Maybe we want to answer different question. And the question could be, is the carbon footprint lower than the limit? And that's a much easier question, actually, because now we are not talking about the accuracy, about the predicted carbon footprint, or about the predicting impacts. We are talking about the accuracy of the statement that what we predict is not lower than the reality. And that's much easier to answer. Are there any structural designers here in the audience? Yeah, there are some structural designers. So I think this is familiar for you, this concept. You can simplify your approach as long as you can guarantee that your outcomes are actually conservative enough, so you are not making mistake. And this is the idea actually that we bring into the thinking about actually what we can do, and we can probably use even imperfect models to predict something. And this will not be the reality, but it will be conservative thing, it will be conservative prediction, and it may actually answer this question that we are asking here, and it must be much easier. So we have tried to demonstrate this idea, especially because we have now in Finland, we have this upcoming new building legislation. New Building Act is coming to be enforced since 2025. And we will have to submit for each building permit a climate declaration, and also these building information models will be submitted. The climate declaration looks like that. So you declare for your building and for your building site all the life cycle phases, including also impacts beyond the system boundary, which is Module D, if you are familiar with life cycle assessment. And you are declaring it in kilograms of CO2 per square meter per year. And this is basically what is required. We already have some supporting things like national CO2 database and development of decrees on climate declaration and on material declaration, and national BIM requirements from Rava 3 Pro project. And then will be limit values actually coming in some point, and these values will be limiting the total carbon footprint. So that is kind of expected, but we still don't know what are these values going to be. Well, if we look at the Finnish emission database, it is very similar to Åkerbau or other databases that are around, or Environdec collection of EPDs. We have different materials and we have different impacts, usually in various units, in per square meter, per cubic meter, per kilogram. If it is transport, it could be per kilometer, or per ton kilometer or something like that. So we have this kind of impacts there. And the only thing that we need to do, actually, there are some building services are actually very much simplified in Finnish database. You don't need to really have them in the design for the building permit. You can just calculate this per square meter. You can take the value from the database. So at the end, you will have to end up anyway with kilograms of CO2 per square meter per year. And this can be done pretty much automatically. So we try to develop this kind of proof of concept tool where you feed in the model. It could be IFC step file, or it can be JSON, and with some connection to dictionaries and databases, you will get out JSON output usually with the results. There's no possibility to demonstrate it as such because there is no user interface here, as you see. It is just everything is running in the background somehow. So it just looks like that. But there is a GitHub, you can download it, you can experiment with this. Basically, this can be running in the background of some administration service, or it can be some other tools integrating this thing. But obviously, you are wondering about this quality of model data and how we are handling it and how we are making sure that what we predict is not really giving false positive values. So it is not unconservative. It is always conservative. So we have this kind of points here that we are addressing. if it is missing material identification. We are still taking some material from the database, but we are always making sure that it is the highest possible material that can be used for this type of element. If we are missing quantities, we are trying to calculate it with some conservative approach. If we don't have exact material name that we are expecting, we have a mapping dictionary now, but we are now experimenting with large language models in Accord project. So probably we will have this AI in the background. And so on. So, of course, if designer gets like negative result, he wants to get some feedback what can be improved, and that is nowadays in a form of a list of elements that were failing, some criteria for material identification, for quantity takeoff, or something else. We can think about BCF probably coming out of it, but it is not yet implemented. And we can also make some kind of indexes like quality of the model in terms of quantities and materials. So I can just show you, we have tested it on several models with different qualities of data from Tekla, ArchiCAD, Revit, ArchiCAD, or we have tested many more, but the basic idea you get here that you can get some carbon footprint per square meter per year. It is usually, if you get lower quality, the prediction is higher. So it is then maybe you are not reaching the limit and you have to get back and try to improve the model. Then we have tested it against some like building. This is like courthouse in Pori, where the LCA was also done by professionals, by some software and experts, and they predicted 19 point something kilograms per square meter per year, and in this tool the maximum value was, okay, maybe I have it here, 27.7. Also we can get minimum value actually, because it is taking from the pool of the possibilities, so it was 18.2, and the professional, like the official calculation was 19.3, so it is somewhere in the range. I mean, if there is a limit 30 kilograms per square meter per year, this calculation will pass, and you don't even have to pay the license and experts to do the calculations for you, because the model data is already showing that this can pass 30. If the limit is 25, you say that it is not passing, but it is possible to maybe improve the model to get better values. If the limit was 15, it is not passing, and you will have to not only improve the model, but you will have to probably redesign something, because even the minimum value is higher than what you are getting, or you should be getting. So this is the idea, and this is a proof of concept tool. So of course this is the development stage, but we have it published in GitHub, so you can study it and try to maybe contribute with some ideas. It is adjusted to Finnish regulations, and we are planning to integrate it with machine readable actually rules for checking these limits. And we are now discussing with Solibri, Cloud Permin, and Future Insight if we can integrate it in some larger systems. So thank you very much.
Thank you, Peter. We are running a little bit out of time, but there is time for one question, maybe. Just one question by myself. Do you think that the ongoing development of the regulations in Finland may affect the implementation of the solution, or it is quite flexible to implement eventually changes?
Yeah, I mean, we are already pretty sure how the regulation looks like, so we don't know the limits now. So the implementation, then it doesn't depend on the regulation development, but maybe on the market and companies who are taking over this.
Okay, thank you. Very short. Okay.
You calculate the values by square meter for each year, but your calculation, is it about the volume of all building materials, or based on the square meter of all the space objects.
I don't have only 10 minutes here, so I didn't say everything. But of course, the calculated total kilograms or tons of CO2 are just converted into kilograms of CO2 per square meter of floor area of the building per year, which is like taken as a 50 years design life. This is the standard value in the Finnish design. Yeah.
Thank you very much. And the next speaker is Mariana Ataide from Fraunhofer Italia that will present a maturity model for digital building permit. Thank you.
Thank you, Silvia. I'm Mariana. I'm from Fraunhofer. This work was done for Czech project with Oriola, Dietmar, and Francesca. Okay. Nope. Oh, sorry. So as we know already, digital building the building permits in general, they are complex processes. They have like a high difficulty to implement, and there are sort of lack of focused solutions, especially when we are talking about maturity models. So our question is how to successfully transition from early DBP model or from analog building process to a fully digital model with data-enabled processes. So for that, you have to know where we are. We have to also know where we want to be, and that we can trace the path for achieving to this solution. And this led to the goals of this research, which were being able to understand the current state of one organization that wants to implement a DBP process, create and achieve an achievable action plan that can support the strategic decisions of this organization. And the third, that it's more related to check the ability to adapt to multiple scenarios and increase the scalability of this. So for that, our work methodology was first data collection and analysis, where we understood like the current building permit processes. We did a research on maturity models, not only related to BIM and GIS, but also to other industries. And our vision to building permit process to a fully digitalized building permit process, which is the Czech DBP process that will be presented tomorrow. So from this, we synthesized a preliminary model. We had some reviews from experts, and then we had like our maturity model. From the maturity model, we got to our roadmap, and then from this, there is also a virtual assistant that we will be also presenting at the end of this presentation. And so to understand a little bit, we know that we have like these three critical dimensions of DBP process. There are procedures, organization, and technology. We find a lot of content in the three categories separately. We can also find some maturity models on each category, but in the middle, there is a lack, and that's where we created our DBP model, maturity model, with our four categories, which are process, organization, technology, and information. For practical reasons, we separated the technology and the information into categories. And from these four categories, you can measure the maturity assessment of an organization, knowing like the current state of this organization and the desired state that the organization want to be. So the categories we showed already, and from these categories, we have like some capability models. There are some capability sets. There are combined areas within the categories. And the key maturity areas, there are the specific areas that will be evaluate according to the maturity model. From this, we have like each key maturity area, which I will call KMA just to be easier. We can evaluate from non-existent to an optimized and automated level of maturity. We try to choose the higher levels with the technologies that we have today accessible, but we know that technology is a fast-growing evolution, so of course this can be extended in the future. But so far we try to put like the technologies that we have available today. And so from these, in our maturity model, we have lost 4 categories, 12 capability sets, 35 KMAs, and each KMA is 6 maturity levels. And for obvious reasons, I'm not going to explain everyone for you. They are accessible online. But just to understand a little bit, the process capability, like higher maturity, indicates like an standardized and streamlined processes aided by data technology. The organization, we have higher maturity, indicates like an institutional support and cultural environment for digital transformation. The technology are the technologies that means a robust system enabling fully automated digital workflows through data technologies. And information is the information that will be used inside these technologies. And they indicate like comprehensive, trusted, and supporting workflows and reducing loss and redundancies of information. So these we have like our KMAs. From each KMA, we can define the current level, we can define our desired level. From these, we have the levels that we already achieved, and then the levels that we have to overcome. And these, in between, are actually the actions that you need to take from the current to the desirable, and these will define the roadmaps, which is a list of actions. But we have to bear in mind that some actions, some KMAs that will depend on other KMAs, which means that, for example, if you have like a transparency and you want to achieve a higher level of transparency, you also need to achieve a higher level of information accessibility. So these dependencies also define the roadmap that we create, that it looks kind of like that, where we have like the KMAs, the dependencies, the actions, the resources available. These resources, they are related now with check, our check tools that we will have in the future, and some project control and the timeline of the project. So kind of to conclude, we had the goal to understand the current and the future situation, and this could be achieved by our maturity model. We could create, we had the goal to create a plan for strategic decisions, which is our roadmap. And we come to a question that is how to create a method for assessment that can be efficient and scalable. And for this, we have our Check virtual assistant, which is, we try to combine the idea of a chatbot and that could assist the assessment of the maturity model, and we try to use large language models, AI algorithms, to analyze the municipality capabilities and to provide tailored solutions based on our maturity model and the roadmap. So here we have like a short video demonstrating how this virtual assistant works. So it's basically a chatbot where the user can talk with we call it IntelliCheck, and then the user can input the process steps, and by the process steps, the virtual assistant will help on defining. This is standardized according to the standardization that we create for the process map. And the virtual assistant will also help to define kind of the current level, but the level of maturity, but this occurs in the background. And then the user can describe each step of the process. And then the virtual assistant will do this definition of the process steps and also of the current level of maturity. And once the process is completely done, like the total current process of the building permit, the chatbot creates the assessment of the categories, of the 4 categories that we have. And that's all for today.
Thank you, Mariana, for your presentation. Any question about the Czech maturity model?
Thank you for the presentation. I wonder if this maturity model is like country specific or Czech project specific, or do you intend to, use this tool to check for like every country's? Maybe also, is it like a national municipality level, or is it like organization level? Because I noticed that there's an organization part of it. But do you imagine that it could apply to maybe a specific organization in terms of if I want to adopt some level of, automated compliance checking or digital building permitting? Is that suitable? Thank you.
Yeah. So we have 4 municipalities in Czech from 3 different countries, and we had a lot of research on how the building permits are done in different countries. So this is not specific to one country. The idea is exactly that we can scale these for different countries. It's more done in an organization level, not so much in the national level, but focusing more on the municipality or an organization that wants to implement like a digital building permit. And I think I answered your question. I don't remember if there was any more. But yeah, the idea is that it can be as much scalable as possible. It's not just related with Czech, the maturity model. The roadmap is more specific, but you can also adapt it to the other technologies, of course.
Thank you, Mariana. And with this presentation, we close the research presentations. Now we move to the practice-oriented presentation. And the first speaker in this sense is Tina Tavitier from the city of Helsinki that will discuss their experimental transition model to implement the digital building permit, also influencing and taking into account users and top management perspective.
Yeah, thank you, Silvia. And hello, everyone. Great to be here today. My name is Tina Talvitie, and I work as a city geodesist at the city of Helsinki in Finland. My background is on private sector. I have been promoting digitalization of construction industry in both software and construction companies. So, at first, let's imagine that you or your friend is about to buy a new electric car. So how would you start designing your car? I suppose you would go to the vendor site on internet and choose the right car model. Then you would try different kind of colors, wheels, materials and equipment. And you could rotate the model as you like, see it from every angle. And as we all know, this is already commonplace. And how do we design our cities? Here on the left, you can see materials related to building permit process of a new building. The same material is used in a neighbor consultation. It's not so easy for the neighbors to understand how a new building would look like in reality when built. How high is the building? How does it shade other buildings? Or is the suitability to landscape or to the surrounding nature? How about if we would have a city design studio, likewise when designing cars? Here on the right, you can see the same new building embedded to our Helsinki 3D city model. In a digital twin platform, you can rotate the model and choose the viewpoints you like. The neighbors can also leave their comments related to neighbor consultation through the same digital twin platform. So I ask you, what is the smart city maturity? How capable are we at utilizing digital twins in daily operations in our cities? Actually, how many 3D city models are integrated to cities' urban processes? Well, I think technology development is pretty fast, and we also have advanced software available. So why is the deployment struggling despite the advancements in technology? Well, when commuting in the morning traffic to work, whether you go by your own car or perhaps you use public transportation or perhaps you go by bike, how often do you think about the technology of your transportation, horsepower, power transmission or something like that? Or do you more like concentrate on getting work on time, the comfortness and safety of traveling? Well, technology itself, it's not so interesting for the users. Technology is a great enabler, but it's not so easy to sell and convince customers of technical issues without practical use cases with benefits. So, would it be easier to start from the user needs, covering user stories from real users? Because users are always the best experts of their own work. So why not participating them into development work? Well, as already mentioned, the Finnish Building Act will come into force in the beginning of next year. It will require interoperable, machine-readable building permit applications. In our Rava-free project, Rava-free Pro project, that was a national development project funded by Ministry of Finance in Finland. 23 municipalities were involved, and the target of the project was to further develop and automate the building permit checking process. And now it's time for the Finnish municipalities to start implementing the results of Rava-free Pro, developing technical capabilities and expertise, defining BIM-based building permit checking process. But at the same time, this change presents a great opportunity to harvest the benefits of BIM modeling throughout the life cycle of building construction. We can streamline the BIM-based workflow, we can involve experts and create enthusiasm. I think we need leadership for promoting digital transformation. We need a cultural change in mindset, or do we even need a cultural revolution? What do you think? We need to question traditional ways of thinking and working. We need leadership for leading people through this change with power of experimental culture and also adapting lean principles. In Helsinki, we have established a concept lab as a platform for experiments, for responding to user needs and user stories. The process starts from focused innovating in workshops. Our service unit people ideate, develop their ideas and define use cases. They combine their service unit's own data to 3D city model data. And our target is here to show with practical use cases, the benefits and possibilities of digital twins. These ideas are then concepted and they are pitched to a steering group. And we follow the fail fast principle. The winner teams get to implement their concepts as proof of concepts with financial support. Well, because of a limited time, I can refer that if interested, you can find examples of our proof of concepts on Helsinki channel. These result videos are spoken in Finnish but subtitled in English. And also in Rava Free Pro, we made plenty of pilots. There's an example of a 4D scheduling. And I will show you now a very, very short video example of a proof of concept result project. It's related to building permit process and neighbor consultation. I hope you see the subtitles there.
Näkökulmista. Malli mahdollistaa näkymän katselun myös eri ajankohtina, jolloin myös varjot ovat realistiset ja lankeavat oikein. Havainnollisuus etenkin hankkeeseen perehtymättömälle on parempi. Yhdistettyä kaupunkimallia voidaan hyödyntää niin kaupunkikuvatyöryhmän käsittelyssä, alueryhmien työskentelyssä, yksittäisen hankkeen lupakäsittelyn tukena, mutta myös...
Thank you.
Much, Tina, for timing also. Any super short question for Tina? Otherwise, after there will be the coffee break also. Okay. So thank you very much.
Thank you.
We can go to the next presentation that is given by PwC Luxembourg, and in particular Giulio Milanesi and Miguel Pereira, that will present the results of a project for supporting public authorities in the implementation of digital building permit at the European level.
Thank you for the introduction. Hello everyone, my name is Miguel. I'm here with my colleague Giulio. We both work at PwC Luxembourg, and today we would like to present the project that we have been working since last year. This project is funded by the European Commission, more precisely DG GROW and ESMEA, and the main objective of the project, the first one, is to analyze the state of play of the current level of digitalization of building permits across EU municipalities, and also how to support municipalities to achieve a higher level of digitalization. So for this first goal, and to achieve this and measure this level of digitalization, we started by defining 4 different levels of digitalization. This was the framework that we came up with. So 4 different levels. First one, very traditional one, paper-based, so municipalities using submitting documents, submitting the building models still completely in paper form. Then we have the level 2 of digitalization. Here is where most of the municipalities across the EU are right now. So these municipalities already have established a website, a platform where they provide information to the applicants. They allow applicants to submit documents, building models through 2D digital forms, namely PDFs. And here in this level still there is no automation on the compliance check. Then level 3 and level 4 are related to BIM, but has the level or the uptake of BIM across the municipalities in the EU is very low. We assumed here municipalities that are already doing proof of concept or a pilot or a prototype with BIM and GIS. So level 3 municipalities that are already trying at least implementing BIM. The automatic compliance is not mandatory but can be available. And then level 4, where BIM is already trying to be implemented with incorporation of GIS, and at least part of the regulation they are working to automate part of the regulation. So based on this framework, we launched a very large survey to assess the level of digitalization of municipalities within the EU. we were able to get 58 municipalities on board across the 27 member states. Here we have the number of responses from our service. So we see more questions on Finland, Italy, and Sweden, which allow us to do let's say, a complete assessment of the country. And then we have a few countries with only one answer. Nevertheless, there are some countries where the building permit process is the same across the whole country, as Greece, Slovenia, and Cyprus, meaning that only one response would allow us to do a full assessment. So, based on this survey and several interviews that we did, mainly with EU front runners, I would like to give you a few main takeaways of their process and how is the behavior of municipalities across the EU. So we got that 58% of municipalities submit documentation via PDF, while 21% of these municipalities still do it via paper form. Then we have that 62% of municipalities submit the building models through PDF, while 19% still does the drawings in paper form. Also, that 78% of municipalities check the building permit rules and regulations manually. The rest have some part of automation within the process. And lastly, that 57% of the municipalities plan to implement BIM in the building permit system in the near future. The ones that have no prospects for that implementation states that adaptation and updating regulation is the main obstacle that they are facing. Then here we have this graph which gives us the distribution of the level of digital maturity of building permits per municipality size, and clearly see that larger municipalities tend to be more digitalized. However, we can see already a small and a medium municipality already in level 3. Even though these municipalities face a lot of challenges as financial capacity, technological means, scarce of resources because they are much smaller, we see that in terms of process, sometimes for these municipalities it's easy to change as they have a bit more flexibility. Also, here on the bottom left, we see the distribution among the 58 municipalities. So we see that the majority clearly at level 2, and then we have still 13 municipalities that use the traditional way of doing the building permit process, which is paper-based. Then I pass to my colleague, Giulio.
Thank you, Miguel. We will now go through, so thanks to the research that we've done, and Miguel just explained, we were also able to identify who are the front runners, so who's leading the way in digital building permits in the EU and outside. Some of these, we had the chance to just listen to them or earlier, or we will have the chance to listen to them later today. So you can see with what we consider as the front runner in the EU definitely is Estonia, which, as Jaan just reminded us earlier, is implementing full-scale BIM and GIS-based permit system in the country. Nevertheless, also Finland, as we heard earlier. Internationally, we found through desk research and some interviews that the UAE, so United Arab Emirates in Dubai, are also very advanced in this regard, as well as Geneva in Switzerland, and these are actually and Singapore as well. So these are the examples that we found the most advanced according to our classification. Then moving on and drawing some conclusion in terms of what we found based on our research activities. So first of all, municipalities they need to start by having what we call an online platform. So meaning even having a platform where citizens can upload documents is the first step to then move to anything that is more advanced, such as BIM. As we saw and as Miguel just explained, that is not a given. Not all municipalities have that. So that's already a step towards digitalization. Then, of course, sounds obvious, but it's a huge topic. The financial and technical support the municipalities need in the digitalization process, which also leads to the need of having a clear vision from above. I think that also the example of Finland is a good example, because the ministry is coordinating the Route 3 project from above. Having a clear vision at a higher level of governments help municipalities in digitalizing. And I'm going to go a bit fast now to conclude. Of course, partnership with organizations such as Building Smart, partnerships among municipalities also help, and then policy interventions at EU level, which need to be shaped in this direction. And now to conclude, what we did after all this research and this data, we developed a toolkit to help municipalities digitalizing based on what we found. The toolkit is aimed at public authorities, and it's aimed at those municipalities that want to get started in their process. So it's based on the models that you can see on the right-hand side of the slide, and the objective is to get this process started. Through this toolkit, we are delivering, well, not us specific, but our colleagues, we are delivering a training program across the entire EU. I think some people here are either trainers or beneficiaries of this training program. So yeah, the aim of the European Commission that we are supporting is to foster digital building permits and to get the process started in municipalities and to help them from an organizational and technological point of view to start the process. So with that, I think we use all our time. So thank you all.
Thank you, Miguel and Giulio, for the overview on the state of the European member states and also international about the DPP implementation. Any question? Otherwise, okay.
We see a lot of other projects going on in Europe, and you also have a kind of project or delivered something. And how do you see all the overlap, or how do you deal with that?
There is a question for the European Commission, I think, but no. Well, our project, in a way, indeed falls within existing initiatives such as Check, Accord, to name just two. I think our focus was particularly on the training and the organizational aspect, whereas Check has a different scope from what I know and from what we just heard, actually. So yeah, I think the Commission wanted to probably diversify a bit their strategy in delivering support to organizations in digital building permits, in the way I see it, at least.
Hi, good afternoon. I was one of the Spanish trainers. And the one thing I wanted to tell you is that what I found poor was the number of municipalities. I wish it would have been larger. 3 municipalities in every country. For example, in the case of Spain, I found it very... So I encourage the Commission to repeat the program every year for some years, because there's lots of work to be done among the European municipalities. And I would here, the Madrid municipality came here, and they could enjoy or have this program, but I wish there would be more municipalities interested in this. Thank you.
Yeah. Thank you for your comments. No, I completely agree with you. Our aim, of course, it was to have even more municipalities in the survey, but sometimes it's difficult to reach out to everyone. We did our best to have the highest number of responses that we could. What you said, something that we can pass the feedback to the Commission, and we look forward to see what happens in the future as well.
Thank you very much, Miguel and Giulio. I invite to the stage the last speaker. Actually, before the coffee break, there are 2 presentations, so we are just 10 minutes late. We can do it very well. Good afternoon, Sasa Galonja from the Consortium of European Building Control, that will also present a report delivered by its own organization about the state of digitalization of building processes in Europe.
Thank you. Sasa Galonja, actually from the Slovenian ministry dealing with building regulations, but today in the capacity of CEBC. We are international, mostly European organization, colleagues from all around Europe making the legislation in the field of building control, meaning construction law and things like that, and technical regulations, but also practitioners daily issuing building permit. This is our group that is for more than 30 years old now, and you see the numbers. I don't have time and I don't want to speak about it. We've done this survey and then prepared the report. I'm here because I led that group at that time. One of the first things we found out is we cannot finish by proposing this is the best way to do it, because the systems around Europe are not the same. So we will have to find each country our own solution. But of course, the idea was to highlight some examples that could be used, and colleagues from several countries did that in our report. I will go shortly through the findings. We started a bit broader than just building permit, because we started from the planning phase and ended up with maybe even with the demolition of the building. So the whole span, the questions were about the whole span of the buildings in question. The first speaker this morning had a similar question and came to the similar results as we did. Why are we doing it? Which is nice, because it would be really silly to have two different, same question to the same public coming with a different results. Wouldn't be nice. What we have found, of course, is that it's very active, this area. Every country is doing something on different levels, sometimes on municipal, sometimes regional, sometimes on the state level, depending on their own system. As I said, we were not focused only on the building permit phase, but also what do we need before that and what we need after that. And one of the things, one of the questions was integration with other databases, with other data that countries have. How do they access or municipalities, state, or the client to get the relevant data in digital form, if there is such. Of course, always the BIM is one of the questions we have in our survey and in our, and this is something that is still going on. I would say very much in development. Some elements, I can tell you, it's the permitting phase. Practically every country does it. PDF, not PDF, more already oriented to BIM or other or GIS solutions, yes, but practically every country already has something on this field. But how do the countries are doing the checking? This is already a bit trickier, more difficult, and that's why we have today and tomorrow this conference to show that it can be done, that some countries are already doing it. I take Finland or Norway, but Estonia is also Latvia and Lithuania are very much advanced in machine reading and checking the designs. As I said, construction is the topic that is being more and more in focus. If previously that was not the case, now countries are searching also for the digital solution in the construction phase, and of course in the completion phase when, or there is a use permit or a similar permit or commissioning to the to what we the quality of our work in the end is the quality of the building and the user that's happy in the buildings they live in. What I can tell you at the end is we did this thing in 2017. So this is a second iteration of not the same question, but the same area. And the findings were quite interesting because when we say, do you have some sort of digitalization in the field of construction, the results from 2017 and 2022 when we did this research was not that different. But when you look into details, then you see two trends. One is that everybody started with the put your, forget the paper, make it PDF and send it to the authority. Now, of course, we've seen today that we are talking about BIM. Then the second major finding from comparison with 17 and 22 survey is this shift towards the end of the process. When we started only with building permit, now we are very much into other phases of life of a building. In our, this is the link. We have 70 questions in our, so I didn't have time to explain each and every one, but you can read it. It's PDF. It's free, so use it. Thank you.
Thank you, Sasha. Thank you very much. Any question? I maybe have just a curiosity. Could you please a little bit more elaborate the definition of fully digitalized in the results that you showed? It was not very clear to me.
When we say fully digitized, we mean no longer PDFs.
Okay.
And the whole process, not only the permitting phase, but also going further
But
on.
do you mean BIM has been implemented?
Yes.
Okay.
Yes. Yeah. We didn't. Nobody reported that there would be any other ways than using BIM as a way to do it.
So it's not just related to building information modeling implementation, but also takes into account other aspects of technical innovation. Okay, thank you. And now it's time for the sponsor talk, and I invite Jaan Saar to present and to motivate all of us about digitalizing the building permit on behalf of Future Insight.
Yes, thank you. So bear with me for a little while, then we can have all coffee. But yeah, just a small commercial break, if you will. I'm now, yes, with Future Insight, and a little bit about Future Insight, what we do. We do exactly what is being talked about at this conference. As I briefly mentioned before, Future Insight has implemented BIM-based building permitting in Estonia. It is live. You can go online and you can apply for a building permit, and you can upload an IFC model, which you can do automated checks on, and which you can visualize, and which you can link to digital twins, etc. But that's not all we do. We also do other stuff as well. We think more broadly. We are developing clearly Hub, which is kind of a integration layer between all kinds of information and data and the applications, because we see this problem everywhere in all municipalities and bigger companies as well. You have lots and lots of data, but people don't know about it. In different departments, they look for it, they recreate the data, but it is already there in many cases, and it's used by different systems, and it doesn't connect to between different applications. So you need some kind of an intermediary layer, and this is why we started developing the hub. But today it's all about building permits. Clearly, BIM is a product we have now for some years that we are developing, and it's, you know, software development is a never-ending story. But it's something that we've already implemented as well. I have a few examples. But first, I would start with the why. You know, Simon Sinek, very good TED talker, made a really nice presentation. Why are we talking about BIM-based permits? Why do we need them? And you can spend a lot of time on this, but I will give you 3 very simple reasons. First of them is speed, efficiency. If we can automate some parts of the process, and you've heard it takes years, it takes months. In some cases, it could take weeks, of course. Usually it doesn't. But in many cases, it takes a lot of time. And of course, having automated compliance checks is not the only solution. The bigger problem is, you know, organizational. It is much more about, you know, applicants want to change the requirements. They don't want to check if they meet the requirements. They actually want to change them. So it doesn't solve everything, but it is a way to speed it up and make it more transparent. Depending on your country, depending on the municipality, transparency is maybe a bigger or a smaller issue. In some countries, it's a very, very big issue. And it's probably the main reason why you would want to automate this process. But either way, it gives transparency, and it also standardizes the way we do checks. This is something that is also something that you shouldn't neglect. It helps, especially when you're talking on a country level, then it helps to, you know, all the municipalities can do it the same way. It's not about who you talk to and in which municipality. And the third one is quality. It improves the quality of designs because you have an ability to do checks that probably the municipalities don't even do in practice. At least that's the case in Estonia, as I know it. A lot of municipalities, you should be checking for a lot of things, but they don't. They rely on the signature on the design of the architect or the main engineer or the designer, and the responsibility is on them. But they may make mistakes. Humans make mistakes, and they often don't maybe notice everything. So if we automate some technical checks as well that haven't been done before, we can improve the quality. And of course, it's about safety of the buildings as well. And the fire departments have all been very, very keen on doing these checks because they are the ones because lives are at stake, and they really do these technical checks. Yeah, but we have the technology. It's won several prizes. You know, nice pictures of me there and my colleague Chris, and Arno is there as well. He's here. So yeah, lots of people already involved who are here as well. But a little bit about 2 projects. One is the Estonian BIM-based building permit system, where we integrated with the government system, clearly BIM, and it's a self-service solution. It is totally integrated with the user interface of the government building permit system, where you had the PDF stuff and everything and all the workflow management. But now you also can view BIM models, and you can view them in the surrounding, taking from the digital twin in the context. And yeah, in total we have 47 automated checks, you know, accessibility, housing requirements, safety, fire safety, etc. Not going to go through all of them here. You can go to Estonia and apply for a BIM permit, then you see what I'm talking about. But also another project which I would like to highlight is a pilot we did together with many municipalities and several other companies in Finland. Anna-Riita is here. She can talk about this project probably more. I'm not sure. Her session is tomorrow, so be sure to check it out. And also Ilka from Cloud Permit. We did this together with them. We integrated Again, clearly BIM with the cloud permit system, which manages building permits in most municipalities in Finland. And but there it's slightly less detached from the system. In Estonia, it's very, very tightly coupled with the government system. But again, this is the flexibility you have nowadays. You don't have to put everything into one big system. It can be linked and integrated with several systems through APIs, etc. And yeah, there were a small number of checks done there, just 5 accessibility checks, but it was a really good start for a lot of municipalities, and there's talks now of improving that and taking it further. But yes, technology is there. It's simple, but what is hard is implementation. And that's why I often like to use this picture, because implementation, having really implemented BIM-based automated building permit checks, it's like getting to the top of the mountain. So, and we are all really at the bottom right now. Some are further, some are, a little bit far behind. Some are stuck in snow. We have the technology, we have the gear, we have the clothes, we have the tents, we have, we can keep warm. That is the technology. But the hard part is getting to the top. And of course, teamwork helps. So what is the call of action? What you should do? As I said, technology is ready. You should start sooner rather than later. And start small. You don't have to think about every single thing. You don't have to boil the ocean. What you have to do is you have to start and do it in an agile way, in incremental steps. And you find that it's not that hard. A key aspect is to use always open standards. This was a discussion here as well. But I'm a very, very strong supporter of open standards because they give us the interoperability. They ensure that you're not actually vendor locked in because the data is always accessible and open and you can use it everywhere. And collaborate. That's why we have this great conference and why Future Insight is one of the sponsors, because we really believe in this community and we see that it is an ever-growing community. And in my mind, there's no doubt about it that in the future all building permits will be using BIM and they will be using some form of automated checking. And communication, whatever you talk here, talk to your municipalities, to your governments, explain to them that the technology is there, we should just start doing something and implement it. So with the golden words of Arnold Schwarzenegger, do it now. But now it's time for a coffee break. And join us after the coffee where we will have another great session to wrap up the day. Thank you.
Thank you. Thank you, everyone. And I think we have talked about very interesting topics from the human factor in change management to sustainability and also education. So thank you for your attention and enjoy the coffee break.